उसके बाद आता है सबस्पेस and dimension, linear transformation, representation of linear transformation. ये वाला हल्का सा एक दिन बोले थे एक बार, by matrices. Of linear transformation. इसके बाद आता है linear functional. It has to be touched now. Linear functional and dual space. Transpose of linear representation of linear transformation by matrix. इसमें क्या होता है कि कोई भी this is a linear transformation from one vector space to another vector space when this AU plus BV equals to this relation will satisfy. Okay, this is a linearity condition. So कोई एक linear transformation will be a matrix. There is no difference. Last class में ही बोले थे कि linear transformation is same as a matrix. ठीक, up to equivalence. So, and also I have told you that any vector space is kind of same as Rn. It's depend on its dimension. If V is a vector space whose dimension is n, means it can be represented by n vectors, then you can just imagine this is Rn vectors. Okay. There's no other, as a vector space, there is no difference. Just naming का difference है. ठीक है, यहाँ पे तुम suppose Rn का vector you can read as a1, a2 dot dot an. Okay, and for suppose p and the all polynomial function whose all polynomial whose degree is less than or equals to n if n minus 1. So n minus 1. So for that you can read as a0 plus a1, or you can write a1 a2x a3x square dot dot an x to the power n. Okay. So this is also n-dimensional vector space. This is n-dimensional vector space. You read an element of Rn as this way, and you read an element of Pn minus 1 in this way. So there any other vector space also can be written in other way, but they are all the same. So it is if U and V, if U is a suppose m-dimensional and V is an n-dimensional. So this is a linear transformation for Rm to Rn, and T will be a matrix n cross n. Okay, this will be the number of rows and this will be the number of column. Okay, and how you are going to represent it? So it will depends on the basis vector. So basis vector जैसे तुम चेंज करोगे उस टाइप से ही तुम्हारा मैट्रिक्स भी चेंज होगा अप टू इक्विवेलेंस. ठीक है, suppose I'm taking simple linear transformation from R2 to R2. Okay, so obviously it will be a matrix equivalent to a 2 cross 2 matrix. Okay, so I'm giving a definition x plus y and x minus y. You can check this is a linear transformation. Okay, it will follow the condition. So now let's check what which matrix it is equivalent to. Okay, so you have to start from choosing a basis vector from both the vector space. Okay, and also I have told you that it's not basis vector are not the unicorn. Infinitely many choice you can choose. So मैट्रिक्स डिपेंड करेगा तुम्हारा चॉइस के ऊपर. ठीक है, तो लेट्स स्टार्ट फ्रॉम अ बेसिक स्टैंडर्ड बेसिस. तो u1 and e2, u1 is 1 0 and e2 is 0 1, and both I'm taking our standard basis from the both vector space. Okay, so let's send this basis vector to the this definition. So क्या होगा यहाँ पे 1 plus 0 and 1 minus 0 is 1 1, and the second basis vector is 0 1, which is 0 plus 1, and 0 minus 1, which is 1 minus 1. Now you have to represent this vector in terms of these vectors, basis vectors in R2 image. This is the image part. So in image vector space, you have to express it. So it is 1 1 0. This vector t10 can be expressed as 1 0 1, and t01 will be expressed as 1 1 0 plus, or not plus, minus 1 0 1. Okay, so the matrix will be t equals to, this will be the column vector 1 1 and 1. Okay, this is the coefficient. Okay, this is coefficient corresponding to this basis vector. So this will take the form of a column. First column, second basis vector will give the second column. So you can write also in this way that t first basis vector e1, the second basis vector e2. Okay, in terms of e1 e2 means, suppose let's take another basis vector. Let's take another basis vector in second, same definition, t xy, x plus y and x minus y. The in R2 the same standard basis e1 and e2, and the image set we take another basis vector 1 1 2 and 2 1. Okay, this is also a basis vector. Then check it. So with respect to this basis vector, the matrix will change, but up to equivalence they are the same matrix. You can check the जो रो ऑपरेशन कॉलम ऑपरेशन करने के बाद जो मैट्रिक्स आता है ना, तो we can say that these two matrices are equivalent. So in this way they are not equal, they will be equivalent. ठीक है, तो इसमें भी t e1 will be e1 is 1 0, so you can write 1 0 1 1. So 1 1 को एक्सप्रेस करना होगा इस बेसिस वेक्टर के रिस्पेक्ट में. So you can see that just in c1 1 2 plus c2 2 1. You have to find c1 and c2. t01 will be 1 minus 1. It will be suppose d1 1 2 plus d2 2 1. तो मैट्रिक्स क्या होगा c1 c2 and d1 d2. While you have to find c1 c2 and d1 d2. It will be the linear equation. Suppose यहाँ पे क्या होगा c1 plus 2 c2 is equals to 1 for this equation, and 2 c1 plus c2 equals to 1 also. So you can solve it. Obviously you will find c1 c2, and for this equation you will have d1 plus 2 d2 is equals to 1, and 2 d1 plus t2 is equals to minus 1. Both equations are solvable one, so you will find a unique value. So I'm not going to solve it. So in this way, and also it will depend on the this basis vector also. Okay, so as you know that matrix has eigenvalues, eigenvectors, or you can transpose it, or symmetric matrix. So everything you can apply to a linear transformation also, because they are equivalent. Okay, so for example, you know the eigenvalues, how to find an eigenvalues, but basic definition is coming from the eigenvector, not eigenvalue. First come the eigenvalue, eigenvector, then come the eigenvalue vectors, sorry, values. So any matrix, if you can write for a non-zero vector, you can write in this way, then we'll say this is a eigenvector. Okay, so it is like a linear transformation. Linear transformation में इसको सोचना थोड़ा सा easy होगा. For example, R2 to R2, it is like you want to send a vector and you need another vector multiplied to the same vector. Okay, so this is the eigenvector, and this is the corresponding eigenvalue. In the same way, you can say this is the eigenvalue and this is the corresponding eigenvector. Okay. So this is the same definition. In the matrix, first you find this equation lambda I equals to 0 and solve this equation to find all eigenvalues, and then put that values, particular value, suppose 3i and v equals to 0, and find the eigenvector. So this is the same. Okay. Here you have to find the eigenvalue and eigenvector. So this is a linear representation in a matrix. So this is very simple. So maybe if there is no basis vector is given, then you have to consider the standard basis. Otherwise, uh, the problem will consist the basis vector. So now let's start the linear functional. Second. So linear transformation का भी determinant निकाल सकते हैं, जैसे मैट्रिक्स का होता है. ठीक है. Linear functional. और एक ही साथ आता है dual space. So it is a linear functional is a linear transformation with a special condition that This is a linear, let's call it T first. This is a linear transformation with this condition: AU plus BV equals to TU plus B TV for all U and V belongs to U, vector from U and V. ठीक है, तो यहाँ पे, so for example, you know this is a field, or you can take C also a field or Q also a field. So mostly we take C or R and C. For defining a vector space, you always need a field. Okay? So let's take it C, or we sometimes call it K. Okay, K as a field, because K relate to R and C and Q altogether, whatever the field is. So K itself is a vector space. Okay, it is a one-dimensional vector space like R. Like R2 is a two-dimensional vector space with respect to the field R. Similarly, R itself can be a vector space from a vector space. Its point is a vector. So the scalar. This is scalar, but by definition, you can define it is a vector also. Scalar is also a vector. Okay, means like from the physics that anything who has a direction also is a vector. So in a vector space, this is also, you need a dimension to determine a vector. A vector means how many dimension means the independent. If it is two-dimensional vector, that means that you need two basis vector, means two axes. You can say to specify that vector. Okay, if it can be three-dimensional, four-dimensional, anything, but at the same time, any a vector can be a one-dimensional, means a scalar. Okay, it is a means you can say it as a default case. So R is a vector space. तो linear functional का definition यहाँ पे अगर जो this is a vector space with respect to R, so use R. So this will be a linear functional. Okay, simple definition. Linear transformation already defined. Just I've changed this vector space, arbitrary vector space, to the field, because it is also a vector space. Same definition apply होना होगा. So this is a linear functional. When the second this vector space will be a field. It's a vector space, one-dimensional vector space, you can say. This is a linear functional. So they use the special name phi. Okay, so it will be the same phi for all u v belongs to u. Okay, for example, projection mapping. Projection mapping, like suppose in R2, this is a point AB, suppose. So you project it to the x-axis, so it will be an A, on y-axis, so it will be B. So if I project that vector, let's call it phi1, because the first axis, or you can call it x, it will A and AB to B. So these functions are 2 from R and phi y are 2 from R. This is an example. These are the example of linear functionals. Well, they will form so a linear, they follow this condition. Let's so in general, so phi I will be a linear functional. The definition is Rn का जो होगा x1 x2 dot 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 xn, so it will project to the ith coordinate xi. So this is a linear transformation. Why it is a linear transformation? Let's check this condition. So you have to take two vectors u and v and two constant a and b. U and v means u is equals to u1 u2 dot un, and v is in dimensional vector vn. So if I send u alone, you will find ui. If I send v alone, you will find vi. Okay, and if au and bv, if you add them, you know how you're going to ith term क्या होगा, au plus bv का ith term, it will be aui plus bvi, because addition is component wise addition और multiplication हर एक component के साथ होगा. This is a scalar because it is an scalar. So obviously it is phi u plus b phi, this is say I v. Okay, so this is a linear transformation. Another example maybe that so let's call V is a n square matrix. इसका जो linear trans, this is also a vector space. I have already so all components are from R. So this is a vector space of dimension n square, you know, and I have told you that this is, you can think as Rn square, because as a vector space they are equal. Okay, but you can find a determinant of a matrix, but you cannot find a determinant of this vector, because because this is a, suppose a1 a2 b1 b2, this is a matrix, but as a vector space you can think, the previous class I have told you, as this. But you can find the determinant of this, not a matrix, I'm this uh, this thing. Okay, but you cannot find any determinant, but determinant is not a part of vector space. Okay, determinant is a different thing. It is not a part of this vector space. So as a vector space you can think this is a vector of this kind. Okay, so all n cross n matrix also form a vector space. So this is this v, all n cross n matrix to R. Let's define it, the matrix to as its trace of A. You know how to addition of all diagonal elements. So this will form a linear transformation, and because this is a field, so it is linear functional. So how you are going to check that it is a linear functional, or first you have to check that it is a linear transformation. So two vectors you have to choose, a and b, means two matrices, and two constants c and d, suppose, and you have to send it. So suppose ta will be a trace a and tb is trace b. And a, if एक का एलिमेंट अगर a1 a1 2 इससे डिफाइन करोगे तो ट्रेस क्या होगा, ट्रेस विल बी the diagonal element a11 a22 plus dot dot ann, and b11 trace क्या होगा, b11 b22 dot dot bnn, all diagonal elements. Okay. So if you add two matrix, so इसका एलिमेंट कैसा होगा, इसका होगा c a11 plus d b11 c a12 plus d b12, इस टाइप का होगा. तो इसका ट्रेस कितना होगा, ट्रेस सी ए प्लस डी बी इज द डायगोनल एलिमेंट जितना भी है उसका एडिशन होगा. लेकिन you know from the matrix that trace will be like this, c trace a and trace D, trace B. So from this equation, you can easily transform this dV equals to C TA plus D TB. So this is a linear transformation. So a linear functional. Uh, or let's say another V is a vector space of all polynomial. Previously, I told you that all polynomials whose degree is less than or equals to n. Okay, less than or equals to n और इसका dimension होगा n plus 1. लेकिन if I take all polynomials, so this is an example of infinite dimensional vector space. ठीक है, all polynomial. I'm taking all polynomial. So this is an infinite dimensional vector space. So TPT, this is a example of a linear functional because this is an R. Well, it has to follow the linear transformation rule. So let's take two vector PT and QT. So TCPT, two also constant C and D, DQT. So apply the rule. So because the integration follow the linearity condition, so you can write it in this way. So this is C PT plus D QT. So this is a linear functional. I remember another example. This is a linear transformation, not a linear functional. Not this one. This one. That let's take Pn is an uh, Pn is an the all polynomial Pt whose degree of Pt is less than or equals to n. This is a vector space. So let's call a linear transformation Pn to Pn. Okay. So T Pt equals to d of dt Pt. So this is a linear transformation, not a linear functional. So obviously it will follow a linearity rule because derivative will break in a linear form Pt plus d Qt. Qt. So this is all about derivative now. Pt so this is a linear transformation also. Okay. Is it a one two? Just I'm asking. Is it a because it is a function, so it can be one and one two also. Can it be one or sorry one two? One तो कभी भी नहीं होगा क्योंकि suppose you can send constant polynomial 1 to 0 and 2 to 0 also. So this is not 1 and not 1 2 also. Why not 1 2? Because the degree will reduce to 1. Okay, if you send a n degree polynomial, it will reduce to n minus 1. So you will never find any n degree polynomials का प्री इमेज नहीं मिलेगा. ठीक है, बिकॉज यहाँ पे मैक्सिमम कितना डिग्री का है. It has it consists maximum polynomial of n degree. Okay, so when you send it to there, it will be a n minus 1 degree. Okay, so if you want to a pre-image of n degree polynomial, because it is Pn, so obviously there is an polynomial of degree n. So you want a pre-image of n degree polynomial, that is n plus 1. But n plus 1 degree polynomial does not exist in Pn. So this is not an one-to function. So why we start reading this linear transformation U to V as a special R? Okay, previously I have said that this is any any vector space, but now I change it to a field linear transformation R. So इसमें let's tell you first that suppose Rn, okay, so Rn is n dimensional. N dimensional means you can choose n vectors, okay, which can be represent any vector from Rn. Okay. With the help of this n vector, you can represent any vector from Rn. So let's choose a basis vector v1, v2, vn. Okay. So now if you choose a vector v from Rn, you know that you can write this v in terms of v1, v2, vn. The help of this is the definition of the basis vector. That's why you can write. So it will be like c1, v1. There will there exists c1, c2, cn in R, the field, such that v will be ci, vi. I will be running from I to n. Yeah. So I can, from this definition, I can define a linear functional. I can define that v to Rn are tv equals to, let's call it ti, ci, this particular coefficient. Okay. So this is ti. So there will be n different linear functional tn v equals to, this is c2 c2, this will be cn. Okay. This definition will change once you change the basis vector. If you change the basis vector, the definition will change. Means definition will be the same, the point will be the different. This is a very important linear functional. That's why we start learning this linear functional. So what we'll do, we'll collect the all linear functional, how many you can have different. So यहाँ पे हम लोग collect करेंगे और prove करेंगे कि this will also form a vector space. So let's call this is called a dual space actually. So wall linear functional, this is a V, we start from a vector space V, and obviously because this is a vector space, it will define with respect to a field R. So now this is a V star, it is a dual space. This is defined as all linear functional phi v2r, ठीक है, wall, such that phi is linear. Linear transformation is, you can call it linear. So now we prove this will also form a vector space with respect to R. Okay, So vector space के लिए you have to prove so many uh, conditions. So for first you have to prove V star is a group with respect to some addition or some addition, and with the field there will be a scalar multiplication V, it is phi. So it is a function, not a point. Okay, so I have already told you that any function that if you take C01, all continuous function from this closed interval 01 to R, all continuous function, this will also form a vector space. And how the addition is defined: if you take two function, or you can call vector from C01, you can add them f plus g, and it is defined, obviously it is a function, it will be a function R, and it is defined as f plus g at a pointwise. So it will give this value f of x and g of x. So we'll define the same addition because it is a function. Okay, so v star, let's copy that. So let two define in this way, that phi 1 or phi 2 are as phi sigma, okay, two linear functional from or 2 points from v star, or linear functional. So we'll define this as v equals to phi of v plus sigma of v. Okay. So because this any function will form a vector space, obviously it will also form a group, because it will be associative, it is commutative, and it has a zero. You have to define a zero vector, means phi plus 0 has to be phi. So this is a zero, means this is a linear functional, not a zero vector, linear functional. So how you are going to define it? That you have to define it as v, uh, whatever vector you are going to feed it, it will always give result 0. Okay, so obviously, because by the definition phi plus 0 to v, phi of v plus 0 of v, and this is phi of v plus 0, and this is the element of R. Phi of v is an element of R. Okay, so it will be phi of v. So for every vector, if this equal two, when two functions are equal, if f of x and g of x are equal for all x in the domain, then f equals to g, you can say. So because this v is an arbitrary, so phi plus 0 v, that you can say phi plus 0 is equals to phi. And also there is an inverse element minus phi, you can minus phi equals to 0. So v star with respect to plus will form a group. Now what about the scalar multiplication? You take k from the real number and take phi from v star, and k phi, how you are going to define this k phi? Because it has to be a linear functional again, but you have to define it. So how you are going to define, because this is a function v to r, so you can define it as phi v equals to k into phi v. Yes, this is a real number, this is a real number, so you are multiplying in real numbers, so it is defined in this way. So obviously this will be a linear functional again, k phi. So this is a vector space, this v star is a vector space. V star is a all linear functional from v to r, means to define v star you have to know v first. If there is no V, you cannot say that there is a V star dual space. So you have to start from V, then you will find V star. This is a dual space, you can say. So now you have to find that basis vector of V star, and also to find the basis vector of V star, you have to know you have to start from V. You have to start from V means you have to take a basis vectors of V first. Suppose you have taken the basis vector v1, v2, vn. This is a basis vector of V, and then you can take, or you can find with respect to this basis vector some basis vector, suppose phi1, phi2. And also I have not told you that how many dimensional it will have. So it will be an n dimensional. I will prove it later. So for v1 there, v2 and vn, this v star will have this linear function, linear functional, which will form a basis vector. v स्टार का बेसिस वेक्टर, इसका मतलब क्या है कि कोई भी फंक्शन, यू कैन टेक एनी फंक्शन फ्रॉम v स्टार, it can be expressed in terms of phi 1, phi 2. Means phi, you can say phi 1 c, phi 1 plus c2, phi 2 plus cn, phi n. Means phi actually is a function. So phi of v is a real number. So phi of v is defined as c1 phi 1 plus cn phi n. You are sending v, c1 phi 1 v, cn phi n v. Okay, so this phi is defined in this way. Okay, so any function can be expressed with the help of these basis vectors you have already chosen, and you will find these basis vectors. You will have from to find this basis vector, you have to start from this basis vector. So if you choose another basis vector like u1, u2 dot dot un, you will find another basis vector of v star sigma n. Okay, so let's talk about the algorithm, how we are going to find it. Okay, so there's a simple algorithm. This is a basis vector and this is a linear transformation, or you can call it linear functional because it is a r. So, and you have started from v, that you have chosen v1, v2, vn as a basis vector of v. Okay, so if suppose that v star wall linear functional has the basis vector phi 1, phi 2, phi n, then if you send phi 1, this is a linear functional, means this is a function from v to r, so you can send this basis vector v1. Okay, so it will have 1, and if you send any other vector other than v1, v2 or any other, all give the 0. So we can give a simple definition. This phi I vi vj, this is del ij, you can say. This is a function, delta function. One if I equals to j equals to 1 if I equals to j, and 0 if I not equals to j. Okay, means if you send v2 to v3, this will be 0. If you send v3 to v3, it will be 1. Okay, So with the help of this definition, you can say that phi 1, phi 2, and phi n, this will be the basis vector. Why? Because suppose, because v1, v2 to vn, this is a basis vector. So for any vector v of v, you can express that there is c1 cn such that v equals to c1 v1 plus dot dot cn vn. You can express that vector v. So if you want to send its phi 1 v, तो इसमें क्या होगा? phi 1 v, phi 1 c1 v1 plus cn vn, and because it is a linear functional, so you can write in this way: phi 2 v1 plus cn phi 1 vn. But यहाँ पे हर एक term will be omitted because only this term will survive phi 1 v1 by our definition. Okay, so this is c1. So if I say that for only ci will survive for this v, okay, only this ci will survive if I send this v. So I can change this ci to phi iv. So now write this: phi 1 v equals to c1 phi 1 v1, or any function. Now what we'll do, we'll send any function phi v and phi c1 v1 cn vn. So you can, this is now any arbitrary function that I have taken. So this is c1 phi v1 cn phi vn. Okay, so this c1 you can write phi 1 v. So this is phi 1 v and phi v1. For the next term, you can write phi 2 v phi v2 plus dot dot cn. The cn, you can say that phi n v phi vn. So, and these are all real numbers because phi v1 will give a real number. So you can write that v1 as a real number d1, suppose. So phi 1 v plus d2, this is d2, phi 2 v, and this is dn phi n v. Now I am taking v out, so you can write t1 v1 because all v are common. So you can say d1 d2 phi 2 dn phi n equals to v. So phi v, this v actually. So phi v is equals to this one, and this is equal to for all v. So you can simply write d phi is equals to d1 phi 1 plus d2 phi 2 and dn phi n. So what you have proven? What you have proved? That you can express this any arbitrary functional as a linear transformation of phi 1, phi 2 and phi n. Okay. So any if you to prove that any set of vectors is a basis, you have to prove that it can express any vector as a linear expression, and also you have to prove that set of vectors are linearly independent. So first we have proved that this vector can express any functional. Okay, so if you can prove now this phi 1 phi 2 phi n are the linearly independent, then you can prove that this is a basis vector. So you have to prove this is a this phi 1 phi n are linearly independent. So to prove this is a linearly independent, you have to first to know the Noah theorem. That is that, can I say that, or just simply say linearly independent होने के लिए this equation you have to satisfy C1 phi 1 C2 phi 2 plus dot dot Cn phi n equals to 0, and this will be only 0 when C1 C2 and Cn is equals to 0. This is a simple definition for to be a linearly independent. So let's try this. Start from this equation and C1, C2, Cn are all arbitrary real number. So this this is not a this is not a, actually a number or vector. You can say this is a element of V star or a function from V to R. So if you try to check it, you have to send any vector. So let's send a vector phi 1 C2 phi 2 Cn phi n. We can send any vector, but we'll send the v1. Okay, the basis vector of v equals to 0. So if you send c and phi of v, and this is a 0 function, so it will result 0. So c1 phi 1 v1 plus c2 phi 2 v1 cn phi n v1. By our definition, all will be the 0. Only this one will survive and will be 1, because phi I Vj will 1 when I equals to j, and when 0 when I not equals to j. So only this one will survive. So we can say that this is 1, so C1 is equals to 0. The similar way, when you send V2, you can prove that C2 is 0. When you send V3, you can prove that C3 equals to 0. So this equation only holds when C1, C2, C3 all are zeros. So this phi 1, phi 2 to phi n are linearly independent, and also we have already proved that this can express any linear functional. So this is a basis vector of V star, the dual space of V. Okay, and the definition is the same, because if you, let's take an example. Okay, so R2 R2 का let's take the standard basis vector E1 and E2. E1 is 1 0 and E2 is 0 1. In the previous class, I told you that this is the wrong way of writing, because as a vector you have to write as a column vector 0 1. Before introducing V star, you can write as a row vector also, but V star is you have to write, this is a dual space, and this dual space element is a row vectors actually. Okay. So if this is a column vector, so V star का corresponding vector इस टाइप से लिखना होगा. Okay, so this will be better. You can write, we actually have to write is a column vector. So this is a standard vector you have taken. Now you want to find all basis vector. So all linear functional from R2 to R. Okay. So claiming this phi 1 and phi 2 is a basis vector of V star, uh, defining that phi 1 10 will result 1 and phi 1 01 will result 0 and phi 1 01 will result 0 and phi 2 01 will result 1, because it is phi 1 E1, it is phi 1 E1, and this is phi 1 E2, and this is phi 1 E2, and this is phi 2 E2. So this is, so any function phi, if you now take R to R, any functional, so a claim that this phi can be expressed as the function of C2 phi 2. And why it is? Because you know that phi of V is equals to C1 phi plus C2 phi 2 V equals to C1 phi 1 V plus C2 phi 2 V. Okay, and because this V is a vector of R2, can be expressed in terms of this 1001. So V can be write as let's D110 plus D201. So C1 phi 1 डायरेक्टली लिख देंगे यहाँ पे, क्योंकि D1 D2, so this will result only D1, because just रफली अगर देखोगे यहाँ पे D201, तो ये वाला ब्रेक होगा, because it is a linear functional. So D1 phi 1 10 plus D2 phi 1 01. So this will only result 1 and this will be 0. So यहाँ पे only D1 will survive. Okay, so only D1 will survive. Only D1 will survive, and here only D2 will survive. Okay, so this is, you can this is a linear transformation ka definition, because for any vector R to R, this has to be a constant. So this is a constant. Okay, and you can check, this will form a linear transformation. Okay, so I'm going to mute it for 1 minute or 2 minutes. Okay. Okay, so let's do some examples. Okay, see if I took basis vector of R2 as 2 1 and 1 2 3 1. Okay, this is a basis vector of R2. What is the corresponding basis vector of the dual space? You can write R2 star. Okay, because if you take V is equals to R2, then you can say this is a V star. What is the corresponding V1 and V2? Phi 1 and phi 2. This is like V1 and V2. You know the result that if you send phi 1 to V1, it will give 1, and phi 1 to V2 is result 0, and phi 2 V1 is 0, phi 2 V2 is equals to 1. This is the result. No. So from this result, you have to find phi 1 and phi 2, the function, which will be the basis of V star. Okay. तो इसमें क्या होगा? You have to consider. क्या consider करना होगा? All about the constant, the coefficient. So any uh, so phi 1 V1 is equals to phi 1 2 1. This is 2 1 V1. So this ये क्या होगा? Phi 1 V1 max. This will be the combination of two number क्यों होगा? क्योंकि how can I say, combination of two number means that if you take this standard basis E1 and E2, so this phi 1 E1 and phi 2 E2 is very simple. This is 1 and this is also 1, and all other is 0. So यहाँ पे if you take this the old, this is called you can think as this is a new basis. The old, as an old basis, is E1 and E2 as in standard basis. You can write phi 1 2 E1 plus 1 E2, which is actually 1 totally. This is 1. So this is 2 phi 1 E1 plus 1. No, this is not the way. इसे फाइंड करना होगा. This is the only result you know. इसमें से तुम्हें फाइंड करना होगा phi 1 phi 2. There go 2 1 and 3 1. So let's first imagine this is a any linear functional, any. So if it is Rn, so phi Rn x1 x2, these are all the component of Rn vectors. तो ये वाला जो linear functional होगा वो maximum क्या होगा? इसका ही linear function होगा. x1 x2 all the component का linear function only x1 हो सकता है. तो कोई भी x1 plus x2 plus dot dot xn हो सकता है, या कोई constant multiplication हो सकता है. So simply you can, how can you express this? If I take R2 and if I take two basis vector, two component as A and B, or not A B, that X and Y. This phi, how can you express? This is simple expression AX and BY. This is the simplest. That if it is 0, that A and B both are 0, then this will be 0. And if A is 1, B is 0, then it will as only X. And if A is 0 and B is 1, then it is only Y. And if his A was 1 and B is 1, then X plus Y. A is 1 and B is minus 1, X minus 1, all at the linear functional. So maximum you know that this component का जो फंक्शन है वही होगा लीनियर फंक्शन, ऐसा नहीं एक्स स्क्वायर हो नहीं होगा, ठीक है. तो इसीलिए दैट्स व्हाई सो ठीक है. तो यहाँ पे दिस इज गिवन फाइव वन वी वन इज इक्वल्स टू वन. सो फाइव वन वी वन का टू कंपोनेंट्स वी वन इज 2 and 1. दिस इज 2 1 इज इक्वल्स टू 1. सो 2 1 का ही फंक्शन होगा. तो लेट्स कॉल इट 2a and 2a plus b equals to 1. Just like before that phi xy is equals to ax plus by. मतलब कोई भी फंक्शन होगा इसी टाइप का आएगा. You cannot change it. And also if you think that t is a linear transformation r2 to r2, if this is a linear transformation, you can send this vector to or again ax plus by and cx plus dy. The linear every component with the linear function of the previous component. Okay, इससे ज्यादा ऐसा नहीं होगा कि x square और sin x cos x, linear function होगा of x and y. Okay, so इसीलिए तो we have considered that this is some linear combination of these components 2a plus b. So this is one definition, because if you say that phi 1 is a single one, xy is equals to ax plus by. So to find phi 1 you have to find a and b. So phi 1 के लिए ab. So to send phi 1 to 1 will write a2 2a plus b and phi 1 दूसरा वेक्टर कौन सा था 3 1. 3 1 will be 3a plus b. Okay, so this is 1 is given and this is 0. You can solve these two equation. So it will be like minus 1 by the, so यहाँ पे a is equals to -1. a is -1, so b is equals to, b क्या होगा फिर, a is equals to -1, so b is equals to my 3. b is equals to 3.
3.
Okay. So the function is phi 1 xy is equals to x minus x plus y. This is the functional linear functional definition. Function का definition तो इसी टाइप से दिया जाता है ना. You have to send a vector, send a point and to an image function. And now all you have to find phi 2. So again we have considered phi xy is equals to some cx and dy, and phi 2 u1 or phi 2 v1 is 0, this is given, and phi 2 v2 is equals to 1, this is given. So phi 2 v1 is 2 1, so this is 2c plus d, which is now 0, and phi 2 3 1 3c plus d is equals to 1. So क्या होगा, c is equals to 1 and d is equals to -3 then. Okay. So now phi 2 xy is equals to 1 1 x
So d is equal to -2.
-3y.
So d is -2.
-2.
Yes, sir.
हाँ हाँ, ओके सॉरी, -2। ये ठीक था ना? फिर यहाँ पे तो गलत लिख दिया। ये ठीक है। b इज इक्वल्स टू 3। हाँ। हम्म, ठीक है। तो दिस इज 5 1 -x + 3y, and this is 5 2 x -2y. Now remember the representation, matrix representation of any linear transformation. So if T is a Rn to Rm, so T is a matrix with of m cross n. ठीक था ना? M cross n. And T is like you have to send a basis vector of U1 first column. How you are going to find the first column of this linear transformation? First column. To find the first column, you have to send the first basis vector and express it as a first basis vector of this vector space, and component wise उसको लिखना होगा, जो भी component आएगा उसको लिखना होगा। तो this linear functional is from R2 to R. So this is actually 1. So phi is equivalent to a matrix 1 cross 2. 1 cross 2 means दिस इज अ एक्चुअली रो वेक्टर होगा, क्योंकि एक ही रो है, सिंगल रो। तो दिस 5 1 and 5 2, दिस 5 1 विल बी अ रो वेक्टर एंड 5 2 विल बी अनदर रो वेक्टर। तो इसको लिखना होगा एज ए रो वेक्टर। तो 5 1 का डेफिनेशन कौन सा था? एक्स वाई इज इक्वल्स टू -x + 3y। तो इसको लिखने के लिए 5 1 को लिखने के लिए क्या चाहिए? फर्स्ट कॉलम में तो एक ही एलिमेंट आएगा, सेकेंड कॉलम में भी एक ही एलिमेंट आएगा क्योंकि सिंगल रो है। तो फॉर फाइंड द फर्स्ट, so let's because there is no basis vector are given, those are the another basis vector. Okay, you can take this basis vector also, but because to express it as a matrix there is no basis vector is given, so you can take the standard basis u1 and e2, और इसका बेसिस वेक्टर ओनली वन, आर का बेसिस वेक्टर ओनली वन। ठीक है, कोई भी एलिमेंट लिखना होगा सी का, सी बिलोंग्स टू आर, इट कैन बी एक्सप्रेस एज सी इनटू वन। सो you have to send the first basis vector 1 0, so it will be -1 plus 0, so it is only -1. So you have to express it as a basis vector -1 only. So this is a first column -1, so 5 1 का -1। सेकेंड कॉलम लिखने के लिए 5 1 को सेंड करना होगा 0 1। तो 0 1 is -0 plus 3, 3 into 1 is 3, this is 3। so 5 1 is like -1 and 3। secondly 5 2, 5 2 का डेफिनेशन था xy minus x minus 2y, x minus 2y। so 5 1 1 0 1 1 only, so this is sorry, this is 5 2। so 5 2 का first column is 1, 0 1 is -2, so this is second। so that's why as I told you that vector v which was r2, इसका जो बेसिस वेक्टर है वो वाला 2 1 and 3 1, that was written in a row vectors, but you have to write it as a column vector because v star is a row vector which was -1 3 and 1 -2। okay, so this is totally different. If I just say that 2 1, you can say this is a vector, but if I say 2 1, this is a co-vector, this is a vector and this is a co-vector। just imagine that if you take we have taken 2 1 and 3 1, so now take just 1 0, Okay, 1 0 and 0 1 स्टैंडर्ड बेसिस. सो ये वाला बेसिस R2 है, बट R2 का जो बेसिस डुअल स्पेस होगा उसका जो बेसिस वेक्टर निकलेगा वो वाला 1 0 एंड 0 1 निकलेगा. सेम वेक्टर बट दिस इज अ रो वेक्टर and previously it was column vector. You can check it. Just apply the same rule. Like the any. So phi one, we have all you have to find phi one and phi two, which we have previously imagined 1 0 and 0 1. So phi one xy, this will be ax plus by, and by the rule phi one u1 is 1, phi one e2 is 0, phi 2 e1 is 0, and phi 2 e2 is 0. Okay, so phi 1 has to be this. So phi 1 1 0 will has to be a by this definition, which is given 1. So a is 1. So phi 1 a is 1, and b you have to find b. So to find b you have to send 0 1, which is b. Now this is 0. So b is 0 and a is 1. So phi 1 xy is x actually only. So इसको as a matrix अगर represent करना होगा तो इसको क्या करना होगा? You have to send again. This is another algorithm, okay? But this it seems the same. 1 0 send 1. So this is a first column. First column का first, because this is it will have only one element in the first column or the second column. Phi 1 0 0 1. This is 0, so this is 0. So this is a row vector. So this is phi 1. You have started from e1, which is 1 0. Similarly, you will see that e2 is 0 1, and you will find phi 2, which is actually dual vectors, which is 0 1. Okay, so that's why row vector and column vector are two different things. One is from vector space, another is from dual space. Dual space in itself is a vector space, obviously, because it will follow all the condition of a vector space. But to define a dual vector space, you have to first find a vector space. Okay, this definition is creating, you have created this definition from V, predefined vector space. ठीक है, तो वो डायमेंशन सेम होगा, डायमेंशन ऑफ V इक्वल्स टू डायमेंशन ऑफ V स्टार. जस्ट सिंपल एजम्पशन से हो गया वो वाला. कौन सा एजम्पशन? कि V का जो V तो यू नो ऑलरेडी दैट, because you have taken the V as granted, so you know all about V, that V is an n-dimensional vector space, and you have taken V1 Vn as a basis vector. Now because this set V star all linear functional, so from all linear functional you have chosen n special function phi 1 to phi n, and defined it like this: phi I Vj equals to del Ij, which is 1 if I equals to j, and 0 if I not equals to j. And by this definition you can prove that phi 1 to phi n are linearly independent, and any linear function can be expressed in the form of phi 1 to phi n. So because this is the definition of a basis, so phi 1 to phi n will form a basis of V star, and because this basis vector contains n vectors, so that's why V star is also a n-dimensional vector space. Okay, so इसमें और क्या है? Dual space transpose of a linear transformation. Simple transpose is like a matrix का जो transformation है वो same, but यहाँ पे change होगा. Like A transpose, row becomes column and column becomes row. So कोई भी linear transformation के T is from Rn to Rm. So this is equivalent to a matrix M cross N. So if you want to transpose this linear transformation, so let's call it is small t, let's call T transpose. So obviously it will be a linear transformation from Rm to Rm. Okay, but it is not inverse function. So just its row will become the column and column will become the row. तो इसको घुमा के देख सकते हो कि because this is a matrix, just like any linear transformation equivalent to a matrix, you can think any matrix as a linear transformation. If I given you this matrix A equals to 2 1 3 2 1 1 3, this is a matrix, so you can think A as a linear transformation, and because this is a 2 by 2 matrix, so you can think R2 to R2. And how this is possible? Because I told you this, any vector you can think as a column. So AV will be another vector W from R2. So obviously, so A में अगर कोई भी x y अगर यहाँ पे 1 2 अगर होगा 1 2, तो it will give a two vectors. इसको मल्टीप्लाई जस्ट मैट्रिक्स मल्टीप्लिकेशन होता है ना. सो A एक लिखो 2 1 1 3. So if you want to give a definition of a linear transformation, you have to use xy. So xy के लिए क्या होगा? This is 2x plus y and x plus 3y. So this is a linear definition of a linear transformation. A xy. So you can, if you want to use it as a row vector, so this is 2x plus y and x plus 3y. So this is a definition of linear transformation. So you know the system of linear equation. System of linear equation you can write in Ax is equals to b. Ax equals to b. So if A is an M cross N matrix, so you know that A is a linear transformation from Rn to Rm. So linear equation में क्या, जो system of linear equation होता है उसमें क्या करना होता है? You have to find x, means this image is given Rm. You have to find a vector or pre-image x. Is it possible or not? You have to find Ax is equals to b, because A is actually a linear transformation. Tx equals to b. This b is given. If somehow it is given that this is a invertible, means this is bijective. So you know, for any v belongs to Rm, you will always find an x belongs to Rn, and because this is bijective, though this has to be the same, Rn and Rn. Always will find Ax means has a solution such that Ax is equals to b, and this is the only condition in linear system of linear equation. You can say that it has only one solution. Okay, only one solution कब बोलते हो? जैसे जब obviously n होता है and determinant of A not equals to 0 होता है, and that time you say that this X has the unique one, has a unique solution. Means from this definition you can also say that this is a bijective function, T Rn to Rn.
All can leave.